it's not that way. Let me show you that it's actually not that way. So yeah, y is 5 to the 0 power 1. Let me show you in a way where you two will agree that it had to be 1. It's worth our time for just a second. Let me show you why. You guys know what's 5 to the second power? Yeah, 5 times 5, 25, huh? And what's 5 to the first power? Yeah, that's just one of them. That's just 5, huh? Okay, now suppose I have no idea what 5 to the 0 is. Let's just follow the pattern. Just simply follow the pattern. How does 25 become 5? Maybe that's not enough power. Let me do it with a lower number. How about if I just go like 2 to the 4th? What is 2 to the 4th power? 2 times 2 times 2 times 2. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Okay, what's 2 to the 3rd power? Well, 2 times 2 times 2. 2 times 2 is 4. Times 2 is 8. What's 2 to the 2nd power? 2 times 2 is 4. What's 2 to the 1st power? Well, just 2. Okay, so what's happening? Now I'm about to do 2 to the 0. Suppose I have no idea what it is. Follow the yellow brick road. Yeah. What's happening here from term to term? What are we doing? How does 16 become 8? And how does 8 become 4? And how does 4 become 2? What are they doing every time? Cut it in half. So what's the next one got to be? See? It's the truth. They're not making this up. It's got to be. See, they're dividing by 2 every time, aren't they? Do you see that? What are they dividing by here? Now go back to the 5.
5.
Yeah, they're dividing by 5. 25 divided by 5 is 5. So then what's the next step? Divide by 5 again. 5 divided by 5?
1.
See? It's the truth. Math just follows the truth, like a bloodhound following the scent. They just follow the truth. That's all it is. So anyway, anything to the 0 power is 1. I read math is just following the truth. All right, so anything to the 0 power is 1, but just use your calculator. Just use your calculator. So everybody see what I'm doing? I just plugged in the 0 there. Right, now let me just plug in the 1. So it'd be 5 to the 1. What's 5 to the 1? Just 5, huh? Now plug in a 2. 5 to the 2. 5 squared, 25. Are we good to there? So that's good enough. Let's just put those on a graph real quick. So I'm just going to go, okay, those are just points. You know what I mean? Like X, Y points. So the first one is over 0, up 1. Right there. That's over 0, up 1. We good? Is that too small to read? Over 0, up 1. The next one is over 1, up 5. Over 1, up 2, 3, 4, 5. Does that make sense? So everybody see, am I losing you? You're seeing what I'm doing here. This is how I'm going to do the graphing. I'm just making a table. I've just plugged in. Why? Why did I start with 0, 1, and 2? Those are just easy. You could do any numbers you want. Those are just the 3 easiest numbers I know. Just 0, 1, and 2. Does that make sense what I'm doing? I'm going to do the same thing every time. So when I want to do a graph, this is all it takes. You just make a table, and on the X side, you just put the 3 easiest numbers you know, 0, 1, and 2. And then I'm just plugging those in for X into the equation. 5 to the 0, 5 to the 1, 5 to the 2. Just use your calculator. Get the Y answers. Those become dots on the graph. Connect the dots, you got the graph. That's all I'm doing. So the next one is over 2, up 25. Now that's just like way, way up here, isn't it? So see what the graph does? See how it rockets up like that? Is that making sense? We seeing that? What does it do on the left side? Well, turns out it goes like this. It kind of flattens out. You could find it out if you wanted to plug in more points. I don't care. I'm just going to go find the answer. Which one of those, A, B, C, or D, then, looks like the right answer? B, huh? That's the only one that's rocketing up to the right, huh? Good enough. If you go into more advanced, go into pre-calculus, that we go into a lot more detail about why it's flattening out. That's called an asymptote line and da-da-da-da-da. All kinds of other stuff. For now, they just want you to be generally familiar, able to plug in 0, 1, 2, get some dots, generally know. An exponential graph rockets up on one side and flattens on the other. That's what they always do. So if you wanted, you could put one example of that in your 3x5 card for the exam. Let's try number 2. So we're going to do the same thing. I'm just going to make a little table. Y equals a half to the x. Well, questions on that one before I move on? Okay with finding those points? Okay, let's go to number 2. Y, what was it, a half or? Yeah, half to the x, okay. Y equals a half to the x. So what am I going to do? Same exact thing. Going to just make an xy table, put the 3 easiest numbers there are on the right side, on the left side for x, 0, 1, and 2. So just plug in 0, plug in 1, plug in 2. Use your calculator. You can just make that 0.5. You know, 0.5 instead of, if you don't want to mess with a fraction, 0.5. What's the first one going to be? 0.5 to the 0? Anything to the 0?
1.
1. The first is going to be 1, huh? Anything to the 0 power is always 1. So I'm just going to use 0.5 to the 0. That's 1. And then try, and then 0.5 to the 1. That actually, we don't need a calculator for that one either. That's just 0.5, huh? Anything to the 1 power is just itself. And then how about 0.5 squared? Go ahead, just use your calculator. I think don't you get 0.25? 0.25, is that good? And then we just go to a graph. Now let's just put those dots on the graph. Are we all good so far? So find those 3 dots. Just do your best to estimate, those decimals. Because it's just multiple choice. It doesn't have to be like all perfect exact. You're just trying to get good enough to be able to pick A, B, C, D, which of those 4 it is. And by the way, I never give a none of the above on a graph question. Because I don't want you to be thrown off by something weird. Yeah, so you'll notice that. Well, I guess you won't notice that, so I guess I'm telling you. Yeah, so on the exam next Monday, there's, I think it's 4, 5, 6, I can't remember exactly, I just made it a couple hours ago. 4, 5, or 6 graph questions. And on all those, I don't put in none of the above. I do on the other questions. But on the graph questions, it is one of those 4. You know it's one of those, because I don't want you to be thrown off by thinking something looks weird, he's tricking me, it's none of the above. Anyway, I don't want you to be thrown off by anything weird like that. So, on the graph ones, there's no E. There's no none of the above. It is one of those 4. So, you don't need to do this all perfect. Just generally get it good enough to tell which answer it is. So, over 0, up 1. So, over 0, up 1. There's the first dot. Over 0, up 1. Second one, over 1, up 0.5. What's that? Well, half, about right there. Over 1, up 0.5, is that good? And then over 2, up 0.25. Now, is that higher or lower?
Half of that.
It's half of that, huh? Like 25 cents is less than 50 cents? Right, because this is 0.50 really, huh? 50 cents. So, yeah, that's just like a quarter of the way up, isn't it? It's small. So it's coming down to the right, isn't it? Does everybody see that? It's kind of coming down to the right. Now, what about the left? I don't know, whatever. Maybe that's enough to grab the right answer. Let's go back and see. Is everybody okay with that so far? See what I'm doing there? And all these graphs, I just plug in 0, 1, 2. Use your calculator. Get the answers. Put the dots. Connect the dots. Let's go back. Let's see what we've got. Oh, here, I don't have. Okay, so there's number 2. What did we have? Whoops, we have this. We have it going down to the right. Which one goes down to the right?
D.
Yeah, it looks like D. Looks like it's flattening out on the axis. A also goes down to the right, but it goes down below the axis. See, ours is coming down to the axis line, isn't it? So that's good enough, huh? See, it's not that hard. These will be pretty easy for you, I think. Just get some dots, connect the dots. We just want you to generally know what it looks like. Like I said, higher math science classes, you get more specific. If you're gonna major in some math or science thing, then you would take pre-calc. All right, shall we go on to number 3? I want to try the same thing for number 3. Right now, remember that negative sign is not. It's separate. It's not involved in the power. It's just negative, and then whatever happens with power is separate. So all the answers are going to be negative, in other words, on number 3. So try number 3. Here, I can make it a little bigger. Yeah, right, was -3x, yeah. Okay, yeah, try that one. Okay, so if I plug in 0, 1, and 2, I get -3 to the 0. We know that's anything to the 0 power is 1, so that's -1. And then -3 to the 1, that's -3. And then -3 to the 2, -9. Good so far. So now put those on a graph. We good there? And then, so yeah, put those on a graph. So it's going to be over 0, down 1. And then over 1, down 3. And then over 2, it's gonna be way down. It's going way down, isn't it? I'm kind of out of room to draw it. But it's going way down to the right. Is that okay? As we go to the right there. This is 1, this is 2. It's going way, way down to the right. Let's look back at the multiple I don't have. There's our graphs going way down to the right, going down super fast to the right. Which one of those looks like that?
B.
Yeah, B is going down to the right really fast, huh? So it's pretty easy, huh? If you just get a couple dots. Is that all good? Questions I can answer on that? I think the graph ones will be easy for you on the test. This one on the practice exam, this specific question is on the practice exam because one just like it is on the real exam. So let's do this. This will be a good one to practice. You'll see it in a week for big points. Well, 5 points. Half a grade. It's still half a grade on a test. That's weighty. So give that a try. Can you read it okay? It's y equals 3 to the x minus 3. It'll be something like that. So same thing, xy table, 0, 1, 2. See what you can get. Just use your calculator. There's some kind of funny rules here. I would just use my calculator. Okay, so if you plug in 0, you get 3 to the 0 minus 3, 3 to the minus 3. Your calculator will tell you something tiny, right? 0.037? 2737? So I'm just going to go 04. It's just small. Good so far? 0.04. You guys get that? And then plug in 1. Whoops. Now plug in 1. 3 to the 1 minus 3, 3 to the minus 2. Isn't that like 0.11?
Yes.
So 0.11. Are we getting these okay on your calculators? Are they coming out? Is that making sense? I don't know if you remember, negative powers make fractions. That's why they're coming out those tiny decimals. Negative powers flip them, make fractions. We'll go over it in a minute, a little bit more. But for now, you just need decimals. You know, it's good enough on your calculator. Just grab some decimals. And then now plug in 2. 3 to the 2 minus 3. Whoops. That's going to be 3 to the minus 1. Is that 0.33? Like that? We good there? Okay, so what does that mean about a graph? Let me move this out of the way. So is that okay? Is that making sense for y'all? Are you able to get those numbers? Anything I can help with on that? This is an important question. This will be an exam question in a week. Is this making sense? I plugged in 0. 3 to the 0 minus 3, 3 to the minus 3. I plugged in 1, and then I plugged in 2. Right? And then I used my calculator. Is that okay? You all know where the negative button is in the calculator, which is different than the subtract for most calculators. Okay, so if you can't get those decimals, grab me after class. Just takes a minute. I can show you anything on the calculator. That's just probably take 30 seconds to help you with that. Be glad to do it. Okay, so anyway, now how do we graph? Let's graph over. So over 0, up just like a little here. I'll make 1 way up here. All this stuff is really tiny, huh? Over 0, up just like super, super small. Over 0, over 0, up super small. Over 1, I have to make 1 about here. 1, 2. Over 1, up just a little bit more. Right, because 0.11 is higher than 0.04. And over 2, up just a little bit. So it's slowly coming up, isn't it? Everybody see how I'm getting that? Right, like think about money. 4 cents, 11 cents, 33 cents. It's coming up slowly. Right? At 0, 1, and 2. It's barely coming up. Does everybody, if I went over to 3, if this is kind of confusing, you could do another one. You could always do more. You could plug in 3, and you'll get 3 to the 3 minus 3, which is 3 to 0, which is 1. So at 3, it makes it up to 1. So it is coming up. It's just doing it very slowly. Does everybody see that? So which graph is coming up to the right like that? A. Yeah, it's A. It might look funny, like, no way, that thing's rocketing up. Well, yeah, if you go a little further, it will. If I did 4, plug in 4, it's going to be at 9. At 5, it's going to be up at 27. It will. And, exponential functions do eventually take off. It will. It's just, we just had the slow beginnings there. Is that okay? Think you can you do that in a week? Like that? Everybody good with that? Just use your calculator to get those decimals. If you don't know how to do that in your calculator, grab me after class or before class on next week. Bring your calculator and be glad to help you with that. All right, I'm going to move on if you're okay. So we have, let me just do a fresh screen here. So we have 4 to the x power is 16. They basically want me to find x or solve for x. So how do I find x there? 4 to what power is 16? Yeah, this one you can just tell by looking, huh? 4 to the second power, right? If x is 2 there, if x is 2, then 4 squared is 16. Right? 4 to the second power, 4 times 4. So that one we can solve by observation. Does that make sense? We'll just call that solving by observation. I didn't really do anything. I just kind of looked at it and went, oh, yeah, the answer's 2. When I was at Cal Poly, taking my last semester there, getting my master's, I had a really crazy hard book our teacher gave us. And I remember it was written by a guy named Whittam. I never met Whittam. He was the author of the book. My teacher, my professor at Cal Poly, Dr. Baser, she had taken Whittam as her professor when she'd been at UC Santa Cruz. And he was like a genius boy. He had his PhD, not his bachelor's degree. His PhD by the time he was like, 24 or something. I didn't even have my bachelor's degree by then. He was like a crazy genius. And he wrote this little book that we used in that class. This one, I think, is clear, right? 4 to what power is 16? 2. We just solved by observation. We just looked at it and said, it's got to be 2, right? That's how normal people, not like Whittam, who's too smart to be a teacher. So number 7 now is so easily done. Maybe some of you can do that by observation. 16 to the 3x minus 1 equals 4. I'd be greatly impressed if you could. Can you solve that one by observation? What value of x needs to be here to make that true? That was super hard. I'm not expecting you to do it by observation. What if I taught that way? What if I just wrote, what if I just wrote that? 6 minus 2. 3. By clear observation, the answer's a half. By clear observation. Now, it is a half. I can do it because I've done 10 million of these. But that's a dumb way to teach, isn't it? You know, I'm still mad about Whittem. All right, anyway, let me show you how to do this. How do we do this? We got to make these bases the same. We got to make these bases the same. So that's the main thing you do on these. Everybody hear me? There's one of these on the exam in a week. One graph one of these. So know the game plan. Let me get a fresh screen, get a little more room here. So number 7, 16 to the 3x minus 1 equals 4. Okay. So here's the game plan. When x is in power, that's the unique mark of these. That's how you're going to tell this. Because you know what's hard? You get to a math test, all looks alike, huh? I'm trying to help you not have that experience. What's unique? How's this going to stand out? X is in the power. See how x is up there in the power zone? That's not normal. We haven't had that up to now. That's what's unique about this. X is in the power zone. Okay. When you see x in the power, write that in your 3x5 card. What do? You make the bases. Step 1, make the bases the same. Step 2, powers are then equal. Then the powers are equal. Make the bases the same, then you can set the powers equal. That's the game plan. Okay, what do I mean? 16 and 4 are bases. They're the bottom part. I'll mean by base is bottom part, right? And the 3x minus 1 is the power. Okay, so I'm going to make the bases the same. How can you make both? What number can you make those both be? 4, right? 16 is 4 to some power. What power? 2. So I'm going to put that with the 3x minus 1. So there's step 1. See how I made both bases the same? I rewrote 16 as 4 squared. That's still 16. See how I haven't changed anything? That's still 16. Right? You with me? 4 squared. That's still 16. I just made the bases the same. Didn't I? You with me? They were different bases. Now I made the bases the same by rewriting 16 as 4 squared. Why? Because as soon as you do, you can now set the powers equal. Now for step 2, this power must equal this power. What is the other power? There's no power there. What does that mean? What's really there, invisibly there? 1, because that's 4 to the 1. It's 4, right? So that means 2 times 3x minus 1 must equal 1. Right? That's step 2. Powers have to be equal. You just cut out the bases, in other words. Why? Well, because if the bases are the same, then 4 to something equaling 4 to something else, those powers must be equal, because if they were not equal, if they were different, then 4 to one of them wouldn't equal 4 to the other, would it? Does that make sense logically? Right? If I said, hey guys and gals, I'm thinking of 4 to some power is coming out equal to 4 to some other power. Well, those powers have to be the same. If they were different, like 4 to the 1 wouldn't equal 4 to the 2, for example. Right? Those powers have to, once you've made the bases the same, the powers have to be the same also, or the things wouldn't be equal. You tracking with me? Does that make sense? Once you've made the bases the same, which is what we do in step 1, the powers have to be equal. I'm trying to reach you logically. That's always best. You'll remember it best if you really get it. So not just follow this up, but really get it, right? Does that make sense? If once you've made the bases the same, the powers have to be the same. Because if they were different, like 4 to the 1 wouldn't equal 4 to the 2. And they're telling, and this is an equal sign problem, right? They're equal. Right? So once you've made the bases both the same number, then you can just forget about the bases. The powers have to be equal. And now you can just solve this. Just solve for x. So in other words, distribute. So that'd be what? 6x minus 2 is 1. Add the 2. You know how to solve for x. 6x is 3. What's the last step to get x alone? Divide by 6. So x is 3. 6, reduce it. It's a half. As we observed. So the answer is a half. Did that make sense? We'll do it a few more times. So what do you do when x is in power? Step 1, make the bases the same. Step 2, then you can set the powers equal and solve. Okay, let's try another one. Before I move on, though, is that okay? See what I did there? I took that 16 and made it 4 squared, which is 16. Right? I just changed the way it looks. I didn't change its value. And then the bases were the same, so I could set the powers equal and solve for x. Okay, so on the exam we take in a week, you'll look at this and recognize it, x in power. So when you see x up there in the power zone, I hope you'll have the 2 steps written on your 3x5 card. Step 1, make the bases the same. So I've got to make this base and this base both be the same. So this is where you want to use your calculator. So I don't expect you to just know off the top of your head. What number smaller than both of those can we make those become? What number smaller than both of those?
5.
Yeah, 5. Yeah, because 25, is 5 times 5. And 125, you might not know for sure, but it kind of looks like it, huh? And so I would think 5 right away. Take your calculator, and so just take your calculator out, and go 5 times 5, and sure enough, you'll get 25. So then you go, okay, I know the left side is 5 squared. And then for the right side, just again, take your calculator, go 5 times 5 times 5, just keep multiplying. And how many does it take to get 125? It takes 3 of them, huh? 5 times 5 times 5, just 3 of them. And you find out you got 125. So this one must be 5 to the third. So we made the bases the same. Is that making sense how I'm doing that? So I took the 25 on the left, and it took 2 5s, so 5 squared. I took the 125 on the right, multiply. We're multiplying, right? Not adding. Multiplying 5s. It takes 3 of them. Or you can just check with the power button if you don't want to just multiply 5. Either way. Is that good? Is that okay so far? Can you finish it from here now? So go ahead. So step 1, make the bases the same. We did. The bases match. Step 2, once the bases are the same, you can set the powers equal. Just forget about the bases, huh? And the 2x must equal the 3. Right? The powers must be the same. Once the bases are the same, the powers couldn't be different, or these things wouldn't be equal, would they? Make sense? The powers have to be the same. So the 5 to 1, if they were different, 5 to one of them wouldn't equal 5 to the other. The powers have to be the same. Once the bases are made the same. How do you solve for x there? Just divide by 2. So x is 3/2. That's our answer. Is that good? Is that okay? So again, what do we do? When x is in power, we make the bases the same, and then the powers have to be equal. We can finish solving. Okay. Okay, give that a try. So x in power. So x in power. Step 1, make the bases the same. Now, give you a second. Use your calculators on that. See if you can get that. So the 27, that's 3 to the third power, right? And 6, 5, 6, 1, is it 3 to the 6th or something? 8th, oh, 8th, okay. 3 to the 8th. And then we have the x minus 1 and the 4x. There's step 1. Does that make sense how I took the 6, 5, 6, 1 and became 3 to the 8th, and the 27 became 3 to the 3rd? Are we okay to there so far? Is that making sense? Just use the calculator? Okay. Okay, can you finish it from here now? Now that the bases are the same, the powers have to be equal, or these things wouldn't be equal. Powers are equal. Give you a second. So this power must equal that power, huh? 8 to the x minus 3 must equal 3 to the 4x. That good to there? And then distribute. 8x minus 24 is 12x. How do you solve for x when you have it on opposite sides like that? What do we do? Yeah, either way, get rid of one of them. It doesn't really matter which one, but yeah, you guys are right on. Just get rid of one of those. I'll probably do the 8x from both sides, but you could do minus 12x. That's okay too. And you just want to get rid of one of them. So minus 24 is 4x, like that. Last step, divide by 4. So x is minus 6. Is that making sense? Question. Okay, so number 10. 1 over 25 to the x equals 125 to the 4 minus x. Okay, yeah, let me help you with this one. Honestly, I'm not putting one quite this hard on the exam. It's one of those other ones. I don't remember exactly which one. It's one of those other ones we did. Is one just like it on the real exam. Not this one. This one's a little more tricky. Basically, I don't know if you remember, like a fraction. What makes? How do you? What number might make both? What lower number am I going to use for the base to make both those? 5, right. You're right on the money with that, 5. Now, if that was just a normal 25 instead of a 1 over 25, I would go 5 squared, huh? Because 5 squared is 25. But how do you make it like 1 over 25? What does that? Does anybody remember? What flips it? Yeah, I don't know if you remember. It's a negative power. It's 5 to the minus 2. So that's pretty tricky. Like I said, I'm not giving you one that hard. The other side, 5 to the third, right? 125. Use your calculator, 5 times 5 times 5. And then put back the other stuff. The x is here. The 4 minus x is there. So there's step 1. Base is the same. So that was the trick part. That 1 over 25 is 5 to the negative 2. Negative powers flip things. Can you take it from... So now we say, okay, this power and that power have to be equal. So minus 2x is 3 times 4. So that's step 2. Powers equal, right? So we always make the bases the same, then the powers have to be equal because they can't be different if 5 to one of them is equaling 5 to the other. And then solve it, multiply, be 12 minus 3x. How do you solve for x when you got x on both sides? You just do the opposite of one of them, huh? It doesn't really matter which one. Like I'll go plus 3x to both sides, cancels out there. And so this is 3x minus, so this is 1x, or just x. X is 12. There we go. So is that good? We're going to leave that now. Is that making sense? So when you have x in power, you want to have that in 3 by 5 power. When x is in power, you make the bases the same. And then the powers have to be equal. Because if 5 to something is equaling 5 to something, those somethings must be equal, or the things wouldn't be coming out equal. Those powers must be the same, and then you solve for the powers. Solve for the x, I mean. Okay. A little small for you to read it all. One type of chromium has a radioactive decay rate of 2.5% per day. If 40 pounds of the chromium is available today, how much will still remain after 60 days? Use this and let x be 60. Yeah, bottom line, who cares about all those other words? Blah, 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 whatever. In the end, y equals 40 times 0.975 to the x, and they're saying let x be 60. So plug 60 right there. Make that 60. So y equals 40.975 to the 60. Hit the buttons on your calculator. That's all it is. So don't even need all those words. Just grab that formula, plug in 60. Can you do that, though? I'm glad to help. With the calculator, let me do it with my calculator. Well, I don't even have my calculator. I'm going to use my little cell phone. But hopefully you have your calculator. So, sounds like you're getting it. I don't know how many places they want you to round. What do they say? Hundredth. 100 has 2 zeros. That means the second place, right? They want you to round to this place. So remember how rounding works? You circle the place they want you to stop at, the 100th place. 2 places to the right. You look 1 to the right. If it's 5 or more, you go up, huh? 8.76. So, yeah, is that good? Are you able to get that? Let me help for a minute. 11 and 12 are just that. They're just hit the buttons. Let's do number 12. It's going to be the same thing. So number 12, same thing. They're just, who cares about the words, blah, 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 whatever. So there's the formula, 2, 5, 9, 2, 8, 2, big number, 1.07 to the x. And then they say right here, x is years after 2007. X is years after 2007. Does that make sense? Years after. So in other words, if x is 1, that's the year 2008. If x is 2, that's the year 2009, etc. Is that making sense with what they're saying? X is how many years? So like 2000, they do that all the time in science formulas. They'll have a starting point, you know, when whatever, the internet first came out or when cell phones first started to flourish. And they'll say, okay, it's 2007 is where we're starting, and X is like relative to that, like how many years after that? That's what they're doing. They do that all the time. So X is how many years after 2007. Okay, so what? Well, then in question A, when they ask us about, in question A here, they're saying how many in 2012? So what am I going to do for 2012? What is X in the year 2012? 5, yeah, because that's 5. You just subtract 2007 and you get 5, right? That's 5 years after. So that means just take that formula, plug in 5 for X. That's all that means. You guys have your calculators? So put right in here, just put this 5 in right there. Just make this a 5. And hit the buttons on your calculator. And you'll get some number, which I have no idea. Or maybe I don't want to do it. It's too long. Somebody got a number on that one? How many, what do they want us to round? Whole number. So that's it. Did you guys get that? Is that what you were saying? So that's what you should get for that one. Round, thank you. Round it to the nearest whole number. 363.5656. On that. I just typed in this times 1.07 to the 5th power. On that. Good? Questions on that one?